Write each product using exponents. First, let's take a look at how you can use an exponent. In the expression a times a times a times a, notice that a is used as a factor 4 times. Another way to represent this product is to let a be a base and to let the number 4 be an exponent, with 4 being written as a smaller number above and to the right of a. This whole expression is a power, and it's equal to the original expression a times a times a times a. And the expression would be read as a to the 4th power. So a power represents a product of repeated factors, and the base of a power is the repeated factor, and the exponent gives you the number of times the factor is multiplied. Let's go back to the expression in part A and see how we can write this expression using exponents. The expression is 4 times 4 times 4. So this is a product of repeated factors where the repeated factor is 4. We can also call 4 the base. And the number of times it's repeated as a factor is 3. So if we use 3 for an exponent, another way to write the product is 4 to the 3rd power. And that's the answer to part A. Now look at part B. Negative 2 times negative 2 times x times x times x. Notice that this product involves 2 repeated factors, negative 2 and x. So to write this product using exponents, we can write this as a product of 2 powers. First, let's write a power using the repeated factor of negative 2. So write the base of negative 2. And notice, because the repeated factor is negative 2, it's very important to keep the parentheses so we have the correct meaning of the product, or the power. Now negative 2 is used as a repeated factor twice, so we should attach an exponent of 2. Now look at the other repeated factor of x, and it's used 3 times. So we can write x times x times x as a power x to the 3rd power. Notice the repeated factor is the base x, and the number of times it's used as a factor is the exponent 3. So the whole product in part B is represented by the product of the 2 powers, negative 2 to the 2nd power and x to the 3rd power. Evaluate the expression. The expression is negative 3 to the 4th power. To evaluate a power, what you can do is write the power as a product of repeated factors and then multiply. In this power, it's very important to realize that the exponent 4 is next to parentheses. That means the base of the power is the whole expression inside parentheses, negative 3. So when we write the power as a product of repeated factors, the base negative 3 is used as a factor 4 times. So let's write the product. So we have negative 3 times negative 3 times negative 3 times negative 3. Now to multiply, we multiply the factors from left to right. And you might be able to do this in your head, but we'll show the steps here. Start with the first two factors at the left. Negative 3 times negative 3 is positive 9. So then write the last two factors again. Now take the next first two factors at the left. 9 times negative 3 gives you negative 27. And pull down the other times negative 3. And negative 27 times negative 3 is positive 81. So the value of negative 3 to the fourth power is 81. And that's the answer to part A. Part B. Evaluate the expression negative 3 to the fourth power. In this expression, notice that the exponent 4 is next to a number 3. That means that only the number is the base, so the negative sign is not part of the power. To help you understand this, another way we can write this is negative 3 to the fourth power. That has the same meaning as the first expression. So we can evaluate this expression by writing 3 to the fourth power as a product of repeated factors and then dealing with a negative sign after we multiply. So let's write that as a product of repeated factors. Negative 3 times 3 times 3 times 3. So then we still have the negative sign. I think we can do this one in our head. 3 times 3 is 9, times 3 is 27, times 3 is 81. So the product is 81, and then the whole answer is negative 81. So the value of the power negative 3 to the fourth is negative 81. Notice in part A, the value of the power negative 3 to the fourth power was 81. So it makes a lot of difference whether the 4 is on the parentheses or on the number 3. And you need to pay attention to that. Evaluate the expression. In the expression 2 minus 4 times 5 to the second power, there's more than one operation. So let's review the order of operations. To evaluate an expression involving more than one operation, use the following order. First, do operations inside parentheses. Second, do operations involving exponents. Third, do multiplication and division from left to right. And fourth, do addition and subtraction from left to right. So back in our problem, what should we do first? Well, notice that we don't have any parentheses, so the second thing we look for are exponents. We do have an exponent, so the first thing we should do is evaluate 5 to the second power. 5 to the second power is equal to 5 times 5, which is 25. So we end up with 2 minus 4 times 25. So in this expression, we still have two operations. Which one do we perform first? Well, you should perform multiplication and division before addition and subtraction. So first, we should multiply 4 times 25. So we have 2 minus 4 times 25 is 100. So finally, we're down to one operation, and 2 minus 100 is equal to negative 98. And that's our answer, because the value of 2 minus 4 times 5 to the second power is negative 98. Let's do another problem. 5 plus 6 to the second power divided by 4. Use the order of operations to take the first step toward evaluating this expression yourself. By the order of operations, we look for parentheses first, and there are none, so next we look for exponents. So we have the expression 6 to the second power that we should evaluate first, and 6 to the second power is 6 times 6, or 36. What is the next operation we should perform? You should perform multiplication and division before addition and subtraction, so find 36 divided by 4. It's 9, so we end up with the expression of 5 plus 9, and 5 plus 9 is equal to 14. So that's our answer. The value of 5 plus 6 to the second power divided by 4 is 14. Evaluate 5 between the spheres is inflated with air. What is the volume of the inflated space? The problem is talking about the sphering ball shown here in the picture. The sphering ball consists of an outer sphere and an inner sphere. The inner sphere is where a person rides, and the space between the inner sphere and the outer sphere is inflated with air, and we need to find the volume of that air. We're given the diameters of each sphere in the picture, so what we can do is use those diameters to find the volumes of the spheres and then find the difference of the volumes. Let's start by finding the volume of the outer sphere, and we can use the formula given here in the problem for the volume of a sphere. In the formula, V equals 4/3 pi times r to the third power. R represents the radius of the sphere. So the radius of a sphere with a diameter of 3 meters is 1 5/10 meters. So we can substitute 1 5/10 for r. And now, by order of operations, the first thing we should do is evaluate 1 5/10 to the third power. So multiply 1 5/10 times 1 5/10 times 1 5/10, and you get 3 375 thousandths. Now we're left with an expression that only has division and multiplication, so we can multiply and divide from left to right. We'll substitute 3 1400ths for pi, so our answer will be approximate. And using a calculator, we can find 4 divided by 3 times 3 1400ths times 3 375 thousandths, and the answer is 14 1300ths. Now, because we're finding the volume, we should put the units here. What units do we use? Well, the diameter was given in meters. Seeing this as a volume, we should have cubic meters. So the outer sphere has a volume of about 14 1300ths cubic meters. Now let's find the volume of the inner sphere. Try finding the volume of the inner sphere yourself. Here's what you should have. When you substitute for the radius should be half of 2 2/10 meters, so it should be 1 1/10 meter. Then you should evaluate 1 1/10 to the third power, and you'll get 1 and 331 thousandths. Now you can evaluate 4/3 pi times 1 and 331 thousandths, and when you substitute 3 and 14 hundredths for pi, your answer will be approximate, and you get 5 and 57 hundredths. Because the diameter was given in meters, the volume should be in cubic meters. So the inner sphere has a volume of 5 and 57 hundredths cubic meters, and the volume of the inflated space is the difference of these two volumes. So the volume of the inflated space is about 14 and 13 hundredths minus 5 and 57 hundredths equals 8 and 56 hundredths cubic meters. And that's the answer to the problem.